Alright, this is Unit 8, Probability. Today we're actually going to be doing a review from previous unit, which is going to be solving quadratic equations. We're going to be seeing a couple different ways to solve. The emphasis today is going to be quadratic formula. Alright, let's go ahead and get started with this first problem that you see here. First thing that you typically want to do is get it in standard form, and what that's going to look like is where you get 0 on one of the two sides. Typically I like the x squared term to be positive, so I'm going to actually leave this over here and subtract the 6x over to the left hand side. Now it's going to be 2x squared minus 6x equals 0. Now that I've got it in standard form, I could use quadratic formula. The value of a would be 2, the value of b would be negative 6, c would be a 0 since there's no constant term over here. Instead of doing that though, whenever c is missing, it's actually easier to do the problem by using a greatest common factor. In this case, the greatest common factor is 2x that can divide into each of the terms. That would leave me with 1x when I divide 2x out of 2x squared. And when I divide 2x out of negative 6x, I'm going to be left with a minus 3. This problem is now set up to solve by factoring. So I'll set the 2x equal to 0, and I'll set the x minus 3 equal to 0 as separate equations. Once you've done that, you just solve them independently. So here on the 2x equals 0, you can see I'm dividing by 2. And here on the x minus 3 equals 0, I will add 3. So x will equal 3, x will equal 0. Those are my two answers. And that's it. Alright, now on to this problem. Very first thing is if you see a common factor that can easily divide out that isn't a variable, you should probably go ahead and divide it out. So in this case, I can see that both sides of the equation, everything can be divided by 5. That's something I'm going to do right at the get-go. So whenever I do that, I get 1x squared plus 24, when I do 120 divided by 5, equals 0. Now, once I've divided by 5, now I've got it in standard form. The value of a would be 1, the coefficient of x squared. The value of b would be 0, and the value of c would be 24. So if I want to use quadratic formula, I can, but this is the other situation where it's easier not to. It's less work to not use quadratic formula. What I would do is actually use square root method whenever you're missing bx. So what I'm going to do is I'm going to subtract the 24 over. So x squared will equal negative 24. And then I'll take the positive or negative root on both sides. So x to the first power would equal the positive or negative root of negative 24. Now this is solved, but I've got to simplify this. First thing, the root of a negative. This is going to be the imaginary unit. So x is equal to the positive or negative I times the root of 24. Next thing up is I actually need to simplify that root of 24. So here's how I'm going to do that. I'm going to look for my perfect square that can actually divide into it, other than 1, because that's not going to simplify it at all. Anyways, when I make my list, I see that 4 is the largest perfect square that goes into 24 because it goes into it 6 times. So I'm going to change this to x equal positive or negative I times the root of 4 times 6. Now that's set up to simplify a little bit more. Changing the 24 into 4 times 6, I can actually take the square root of 4. So my final answer is positive or negative 2 I root 6. I was unable to take the root of 6 and I cannot simplify it anymore. There's not another perfect square that divides out of it that would help me. Alright, this is really what I wanted the focus of today to be on, is actually making use of quadratic formula. When I use quadratic formula and when I advise students to use quadratic formula is when there's an a value, a b value, and a c value. Here the value of a is 1. It's not written there, but it's 1x squared. B is 6. C is 9. So you first of all need to know quadratic formula. Boom, I made it appear. So you already have this in your notes. It should be something that you have memorized by now. And what we're going to do is use those values that I just mentioned of 1 for A, 6 for B, 9 for C, and plug those into the quadratic formula and start simplifying this answer down. So where it's negative B, it's going to be negative 6 plus or minus the square root of B squared minus 4AC. So that's going to be 6 squared minus 4 times A is 1 and 9 is C. All over 2 times a is 1. And now I start simplifying things down. For instance, the negative of 6 is simply negative 6. Plus or minus the square root of 6 squared would be 36. And you're allowed to use your calculator through this. When I do negative 4 times 1 times 9, negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36. So I'm going to write minus 36 right there. Over 2 times 1 is simply 2. And now I'll always take this sum or difference that you end up with here, and 36 minus 36 is going to be 0. Kind of a strange occurrence for that to happen, but it does occasionally happen. Alright, now here's where you go. If you can take the root of this discriminant, you should. And we can take the square root of 0, which is 0. And now you'd make two separate equations. However, you probably recognize if I'm adding 0 to negative 6 or subtracting it away from negative 6, my answer is going to be negative 6. So I'm going to make this x equals negative 6 divided by 2, so x equals negative 3. That is a strange situation where you end up with only one unique answer, but it does happen, and that's what you need to do with it, is whenever 0 ends up being your discriminant. Alright, I'm going to be using quadratic formula again, but before I do so, alarm bells should be going off in your head on this problem that you actually need to get this in standard form first. So if you did not subtract the 4 over, you need to be doing so now. So 2x squared plus 7x minus 4 equals 0. There it is. Now we're ready to set it up into that quadratic formula that we just saw. Boom! Made it appear again out of nowhere. So what's going to happen is we just go ahead and drop in the value 2 for A, 7 for B, negative 4 for C. Be careful with your signs. Whenever you got negatives is when things start to get thrown off. So x equals negative 7 for B, plus or minus the square root of 7 squared minus 4 times A is 2, C is negative 4. All over 2 times A is 2. Now we start simplifying down again, and you're going to get used to this process. We only have 2 more problems after this one to look at, so it's going to be consistent in what we do here. So this is going to be negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. And 2 times 2 is 4. I'm going to really quick simplify this discriminant. 49 plus 32 is 81. So negative 7 plus or minus the square root of 81 over 4. And again, if you can square root this discriminant, you should. So that's actually going to be 9. So negative 7 plus or minus 9 over 4. Now when you can square root it like that, you're going to get rational answers. And let's actually see what the two answers are going to be. What I do is I split that into two different things. X equals negative 7 plus 9 divided by 4. The other one's negative 7 minus 9 divided by 4. Because both of those is what this is representing. Now I simplify each of those and I'll have my two answers. Negative 7 plus 9 is 2. And 2 divided by 4 would be 1/2 as one of my answers. Alright, negative 7 minus 9 would be negative 16. And negative 16 divided by 4 would be negative 4. There's my two answers. Typically, that's what you're going to end up with is two answers for these things. Alright, here's our 5th of 6 problems. What's going to happen here is we're actually going to be dealing with something that's already in standard form, but something different is going to happen along the way when we start simplifying it. So I'm going to go ahead and set this up in quadratic formula by doing x equals negative 10. It's kind of strange that the b is negative, but it actually happens almost half the time. Plus or minus the square root of b squared, so negative 10 squared, minus 4 times a is 1, because this is 1x squared, times 23 for c, all over 2 times a is 1. Alright, now we're going to start simplifying it. So that's going to be positive 10, negative 10. Negative 10 squared is positive 100. You just got to be really careful about your signs. Negative 4 times 1 is negative 4. And negative 4 times 23 is negative 92. and I'm going to have that over 2 times 1 is 2. Start simplifying from there. 100 minus 92 is 8. Now, before, on the last two problems, we were actually able to take the square root of the discriminant, but here we are not able to take the square root of 8. It's not a perfect square. So what's going to happen is I'm actually going to be looking for a perfect square that I'll divide into 8, like I did earlier in this lesson. And when I look for it, that's actually going to be 4. 4 divides into 8. So 10 plus or minus the square root of, I'm going to change 8 to 4 times 2. And the reason why I did that is because I'm able to square root the 4. So that goes to this right here. X equals 10 plus or minus 2 times the root of 2 over 2. And that 2 on the outside is coming from the square root of 4. The square root of 4 is 2. I could not square root the 2, so it stays in the root. Now I simplify more because actually 2 will divide into the 10. It will also divide into the coefficient here. So here's my final answer. 10 divided by 2 is 5, and 2 root 2 divided by 2 is 1 root 2. You don't need to write the 1 in front of the root 2. You can just leave that off like I have here. And these are two answers. One of them is 5 plus the square root of 2. One of them is 5 minus the square root of 2. And we're done with this problem. This will be our last problem that we're going to look at. What's going to happen here is yet another situation that's different. It's going to happen with quadratic formula again, so I'm going to go ahead and get that pasted here. And let's go ahead and actually get it set up and going. So there's no common factors to divide out here, so I'm just going to go ahead and set up as negative 7 for negative b, plus or minus the square root of b squared, negative 7 squared, minus 4 times a is 2, and c is positive 8. All over 2 times a, which is 2. And now what's going to happen is I'm going to keep on simplifying that down just as I have before. So it's positive 7 out there, plus or minus the square root of. Negative 7 squared is positive 49. And negative 4 times 2 is negative 8. Negative 8 times 8 is negative 64. And 2 times 2 on the denominator is 4. Now I'll go ahead and do the subtraction. That 64 minus, or 49 minus 64, excuse me, would be negative 15. Now, whenever you see a negative inside the root, that's, again, imaginary root. So you've actually got to represent that with I. 7 plus or minus I times the root of 15 over 4. Because I represents the root of negative 1. What you want to do from here, you want to think about your perfect squares. 1, 4, 9, 16, 25, and so forth. And look for the largest one that divides out 15 and simplify it from there like I did on the last problem. Here, though, nothing is dividing out of 15 other than 1, which is not going to change the 15. It's not going to simplify it. This is actually my final answer right here as far as I can take it. I can't divide 4 out of either the 7 or the coefficient here. You have to be able to divide it out of both to simplify it further. It's done. It's really kind of tricky to know when you are finished. It honestly just takes a lot more practice to get that done. You do have a worksheet to complete with this. So get that done, and I will be collecting that at the end of the unit.